Hola Precalc students, this is Ms. Carranza. Today we're going to talk about 5.4 notes, day 3, continuing to solve trig functions. You'll just see that these are a little bit more complicated than the ones that I gave you for homework previously. Okay, pause the video and take a minute to write down everything that you see on your screen. I'd also recommend that you draw your 30, 60, 90, 45, 45, 90 triangles and your quadrantal angles with your signs. Just make sure that you're using radians. So take a minute and put those right under here. Draw the two special triangles and then your quadrantal angles with the coordinates, the pluses and the minuses. Pause the video and unpause it when you're ready. Okay, hopefully you didn't cheat and you actually wrote them on your own. Okay, for these trig equations, the directions say you need to solve over the domain from 0, which is included because it has the bracket, up until 2 pi. So we're looking at one full rotation. So the highest, so any angle between 0 and 2 pi, if you're thinking degrees, anywhere from 0 to 360. That does not include any negative angles. I want you to make sure that you always provide a diagram when you're answering these questions. Okay. Here's your first example. Okay. If you notice, this equation is not a quadratic equation, so you do not need to set it equal to 0. I'm going to rewrite it and show you how it's similar to this equation. In this equation, since there's variables on both sides, they're linear, you want to move all the linear terms to one side and then solve for x. So since it's being multiplied with a 2, you would divide by 2, and your answer would be negative root 2 over 2. So this is very similar, it's just got the quadratic function of sine. So again, since there are no quadratic terms, you do not need to set it equal to 0. You just got to combine your like terms, your variables on one side. 1 sine of x plus 1 sine of x is 2 sine of x. Remember, one apple plus another apple is 2 apples. Bring down your negative root 2. And then your job is to get the sine x alone. Isolate it. So you're going to, it's being multiplied with a 2, so you're going to divide by 2. And now it looks like the problems that we did in 5.4, day 2. Always reduce your answer if possible. Negative root 2 over 2 doesn't reduce. So notice what I did. It wasn't quadratic, so all I had to do was get all the linear terms on one side, constants on the other, then isolate my quadratic term. So now I'm going to ask myself, sine, remember, is a y value. What quadrants is sine negative in? Sine is your y value, so you're looking at anything in the bottom 2 quadrants. Sine is negative, right? Your answer is negative root 2 over 2, so it's in the bottom 2 quadrants. Now you got to ask yourself which triangle, 30, 60, 90, or 45, 45, 90, would allow me to take an angle and the sine of it be root 2 over 2. Okay, let's say I think of pi over 6. Sine is opposite over hypotenuse. Opposite over hypotenuse would not give me root 2 over 2, it would give me a half. So then try pi over 3. Opposite over hypotenuse would be root 3 over 2, so it can't be root 3. So it's definitely not a 30, 60, 90 triangle, or pi over 6 and pi over 3. Then I look over here. Opposite over hypotenuse would be 1 over root 2. So sine of pi over 2 would be 1 over root 2. And if I rationalize it, that gives me what I want. But remember, that just tells you what the reference angle is. Your reference angle is pi over 2. Since we know that we want the angles that have a reference angle of pi over 2 but are in quadrants 3 and 4, I'm going to make sure that I use a reference angle of pi over 2 and a reference angle of pi over 2. Okay, but just know that your actual angles are this one. So if you label in radians using a denominator of 2, this would be 2 pi over 2. So this would be 3 pi over 2. Oh my goodness, I just realized that I was doing pi over 2 and it was pi over 4 the whole time. Sine of pi over 4. Let's take a look up here. See? Pi over 4, not pi over 2. Pi over 2 is actually 90 degrees. Pi over 4 is 45. That's what I should be using. So I need a reference angle of 45 degrees in quadrant 3. So reference angle of 45, which is pi over 4. Sorry, I had written pi over 2. I think I got it confused because of the root 2 over 2. And then I need a reference angle of pi over 4 in quadrant 4. So one angle is that one, the other one is this guy. Okay, so this would be 4 pi over 4, aka 1 pi. Remember, 4 divided by 4 is 1. And then 1 pi over 4 away from that would be 5 pi over 4. Over here, we've got 2 pi. If you write that with a denominator of 4, that would be 8 pi over 4. And take away pi over 4 from that, and that would give you 7 pi over 4. So again, the reference angle was pi over 4 because that was the only thing that would give me opposite over hypotenuse. That would give me root 2 over 2. I'm looking only at quadrants 3 and 4 because the problem said the sign has to be negative. Pi over 4 is not the solution, it's just the reference angle. You have to think from 0, how do I get to this point, to this angle, right? So that's pi over 4 past 4 pi over 4. And then you also have to ask yourself, how do I get to this guy? You're just 1 pi over 4 short of 8 pi over 4, so that's why I subtracted. So x is 5 pi over 4 and 7 pi over 4. Okay. Go ahead and pause the video, rewind, and rewatch. Just remember I accidentally wrote whoopsies pi over 2 instead of pi over 4 on that one. Okay, when you're ready, go ahead and copy the next problem. Notice that this one is a quadratic, so it's very similar to now in the video where I reviewed some of the algebra skills you would need for this chapter, I talked about how if there's a quadratic term but no linear term, so no x to the first power, you can use something called SADMEP to solve it. It's the backwards order of operations where you cancel subtraction and addition first, then multiplication or division, and then get rid of the exponent. So you would square root both sides. You'd put plus or minus. When you're square rooting a fraction, you have to square root the numerator and the denominator. Square root of 1 is 1. Square root of 3 is square root of 3. You can't have a radical in your denominator, so you rationalize. So your solution would be root 3 over 3. Okay, so this is a quadratic equation. I'm going to use SADMAP. So I'm going to start by canceling addition and subtraction. Remember, you can use SADMAP as long as there's no linear term. Then in SADMAP, after you cancel subtraction and addition, cancel multiplication or division. I highly recommend that you watch the video without writing anything for an example so that you can follow along with my steps and then replay that problem and then copy the steps. Because if you're trying to just copy everything that I'm saying, it's going to go too fast and you're going to miss out on the explanation. Okay, then I get rid of the exponent, so I'm going to square root both sides. I get rid of the exponent. And take a look at, I'm going to highlight it in blue, how you square root a fraction. You square root the numerator and the denominator. Then you rationalize. Okay, now think about what the question is asking you. It's asking you tangent of what angle could be positive or negative root 3 over 3. So I'm going to think about my special triangles, and the only place I've ever seen a root 3 is in a 36 to 90. The only way to get root 3 over 3 is if you have a 1 on the top and a root 3 on the bottom. Remember this guy over here? 1 over root 3, and then rationalize it would give you root 3 over 3. So tangent is opposite over adjacent. Which of these angles, pi over 6 or pi over 3, would allow me to get root 3 over 3, aka 1 over root 3? For opposite over adjacent, well, let's check. Pi over 6, opposite over adjacent would be 1 over root 3. Perfect. That's what we need. Remember, root 1, the square root of 1/3 is the same as 1 over root 3. So that means that we're going to use pi over 6 as our reference angle. Now, tangent is, they're asking you where is it positive and where is it negative. So think back to your quadrants. Oops. It says tangent can be positive or negative, and tangent is the ratio of y over x, sine over cosine. It's tangent. So pretty much you're looking at all the quadrants, because in quadrant 1, positive divided by positive is positive. Here, negative divided by positive is negative, and so on. So you're really, they say that I want the positive or the negative of root 3 over 3. So I want all the possibilities, positives or negatives. So I want all the quadrants. So here's how you draw the diagram. I want reference angles of pi over 6. We said it could be in either quadrant, 1, 2, 3, or 4. Now your job is to figure out what angles these are. This first angle is just pi over 6. You start at 0, you go pi over 6 counterclockwise, so that's one answer. This next one, the reference angle is pi over 6, so 1 pi would be 6 pi over 6. So 1 pi over 6 away from 6 pi over 6 would be 5 pi over 6, because it's before you get to 6 pi over 6. And then this is pi over 6 after 6 pi over 6, so that would be, so now I'm looking at this guy, 7 pi over 6. And last but not least, we want this guy, 1 pi over 6 before you get to 2 pi, which would be 12 pi over 6. So 12 pi over 6 minus 1 pi over 6 would be 11 pi over 6. If it helps, what you can do, and some of you did this when I first started showing you this, is cut the half of the circle into your 6 pieces, each half of the circle. So then you can see 1 pi over 6, 2 pi over 6, 3 pi over 6. Remember, this is always 90 degrees. That reduces to pi over 2. This guy reduces to pi over 3. So it would be 4 pi over 6 reduces to 2 pi over 3. 5 pi over 6, 6 pi over 6 reduces to pi. 7 pi over 6, 8 pi over 6, 9 pi over 6. And notice that some of these reduce, right? So 8 pi over 6 reduces to 4 pi over 3. 9 pi over 6 reduces to 3 pi over 2. 10 pi over 6 reduces to 5 pi over 2. And then 11 pi over 6. All the ones that have a reference angle of pi over 6 are this guy, this one, and this one. And those are the ones that I used in my answer. Okay, when you're ready, go ahead and write down example 3. Okay, this problem is similar to a quadratic problem that looks like this. Notice this is a quadratic. There's no linear term, so I can use StatMap to solve it. And then square root both sides. Don't forget to put your plus or minus. That's super, super important. Whenever you're solving a quadratic and you cancel the square root with the square root, you have to put the plus or minus. Okay, so now I'm going to go ahead and try that here. Square root both sides. So secant of x equals plus or minus root 2. Just like in the basic algebra problem here on the right, we try to get the variable, we isolated it, get it by itself. You're doing the same thing here. You're isolating your trig function and getting rid of any exponents. Now, secant is a reciprocal property. To make your life easier, ask yourself, okay, who is secant related to in terms of reciprocal? It's related to cosine. So I'm going to use the reciprocal. So the answers to both of these are going to be the same. You can use secant and solve the equation like that, or you can use cosine. It's up to you. I'll show you why you can use both. So the reciprocal 1 over root 2, rationalize it, you get root 2 over 2. Again, you can use the secant or cosine, it doesn't matter, but you need to think of your 30, 60, 90, 45, 45, 90. The only angle that has a root 2 in terms of your special triangles is the 45, 45, 90, your pi over 4. So again, you can ask yourself, okay, secant is hypotenuse over adjacent. So if I use pi over 4 and I do hypotenuse over adjacent, I get root 2 over 2. So that tells you that your reference angle is pi over 4. If you decide to use the reciprocal, so change secant to cosine, and then the reciprocal of this guy, of root 2, that gives you root 2 over 2. And then you can, same line of thinking. Cosine of what angle would give me root 2 over 2? That would be adjacent over hypotenuse. That's adjacent 1 over hypotenuse root 2, which you can see over here, highlighting it in blue. 1 over root 2 simplifies to root 2 over 2 when you rationalize it. So it's up to you which one you want to use. It doesn't matter. Okay. I like to stick to using just sine and cosine, so I'm going to stick to this guy. Now, cosine, they're saying that it could be positive or negative. So whenever you see plus or minus, you got to ask yourself, okay, in which quadrants is that trig function positive and in which quadrants is it negative? Cosine is your x value. X values are positive in quadrants 1 and 4. And they're negative in quadrants 2 and 3. So technically, we're looking at the whole coordinate plane. I'm looking for, remember your reference angle is pi over 4. Reference angle equals pi over 4. So I'm looking for all these angles. Do you guys see that it forms like a little bow tie? The reference angle is of pi over 4. Okay, so I'm going to go ahead. This is kind of like example 1. Label this as 4 pi over 4, which is 1 pi. And I'm going to go through and mark all of these. So this is 1 pi over 4. This would be 2 pi over 4. This is 3 pi over 4. Here's 4 pi over 4. This would be 5 pi over 4. This would be 6 pi over 4. And this would be 7 pi over 4, 8 pi over 4. Which reduces to 2 pi. So all the angles that have a positive or a negative cosine of adjacent over hypotenuse, so take a look, remember the special triangle, adjacent over hypotenuse, are going to be all of those angles, pi over 4, 3 pi over 4, 5 pi over 4, and 7 pi over 4. So far we've solved these equations using SADMAP and just regular, so this was a quadratic with no linear term, this was a quadratic with no linear term, we use SADMAP. This one was SADMAP, there wasn't even a quadratic equation. So the next video is going to explain what to do if there is a linear term and you have a quadratic equation. So go ahead and make sure that you move on now to video number 2.